Hello and welcome to the 10th video in the series making a simple Flappy Robin for Android using Cocos2dx version 3. So this video then will be probably a bit of a longer video. The most involved video so far, but hopefully not too difficult. It's going to involve actually putting the tubes on the screen. If I just go to the sprite here, I've added into the resources, which will be available of course for download, the 3 tube sprites depending on the definition. This is the normal definition tube. It looks like this. And before I start talking about how things, or programming how things, the code in, I just wanted to discuss how things work with the tubes. So the tube is like this, and we can basically have 3 types if you're familiar with the game. We can have one type which is in this position here, a single tube, which the screen cuts off somewhere, anywhere here on the tube to give the impression that the tube is hanging from the top of the screen and the robin has to get under this tube. The other thing we could have is the tube flipped in the Y, so it's actually the other way up, and then the robin has to get over the top of the tube. And we could also have a pair of them, one from the top, one for the bottom, where the robin needs to get through a gap in these tubes. So that's effectively 3 different types of tube. The other thing that's important with these tubes is when we position the tube, if it's one that's going from top to bottom, as in the position as it is now, then we'll set its anchor point actually to the bottom here, the base of the tube, like so. And if it's the other way up, we'll position it again with its anchor point on the base, but of course that'll be effectively at the top side of it because it'll be flipped in the Y, and that's fairly important to know. And the problems that come with programming this, so the things that you need to control in the game, one obviously is the time variance of the tubes being spawned, so how far they are apart in the gap. You want that to be playable but also slightly different each time, so it doesn't look exactly the same. But the other thing we have to control very closely is the maximum and minimum gap that we want between the tubes, and also from top to bottom of the screen where we want sort of the maximum height that a tube in the Y that the base of a tube would be, and also how low the tube can be on the screen. So basically we're going to need to add some constants in that control that, depending on the type of tube that's spawned, whereabouts that gap is, or how low or high the robin needs to go. And I already mentioned in the last video, if the robins had to go under a tube like this, we need to make sure that the amount the robin has to then go up the other side to get over the next tube is actually achievable and not impossible, otherwise the gameplay is pretty bad. Okay, so I'm going to dive into constants.h and then we can start adding some of this information in. The first thing we're going to do is, however, is go to kzindex floor, copy that, paste that, and just put kzindex tube and make that 35 for the z-index for the tube. And I'm going to make some space here then in constants and just scroll things down a bit. And now let's define some of these constants I was just talking about. So the first thing we'll look then is the spawn time. So we'll sayktube and spawn time, and we'll call this actually spawn min time, so that's the minimum time that should elapse between spawning a tube, and that'll be 2.3 seconds. And what we'll also say then is that we'll have a tube spawn time variance, so that means we'll have a minimum of 2.3 seconds, but plus or minus 8 tenths of a second. The reason I've got that 8 and not 0.8 is because we'll divide that by 10 later on so that we can work with integers and find that a bit easier. So we've got spawn time variance here. That means we'll have 2.3 to 3.1 seconds gap between the tubes. Now we've got that done, then we need to have some definitions for the types of tubes that we've spawned. So we'll have ktube type, and the first one we'll have then is upper. So upper is one that goes from top to bottom of the screen, and actually I'd speed this up and just copy this a couple of times. So we'll have lower, pair and none. So none, pair and lower. So a lower then is one that's from flipped in the Y and goes from the bottom upwards, and a pair is obviously both upper and lower with a gap in the middle then that the robin needs to go through, and just set some numbers for those. And now probably the most confusing looking bit is going to be controlling the gap for a single tube and then a pair of tubes on the screen. So the first thing we're going to define is k single gap top, and that's going to be 440, and obviously I'm taking this directly from the Cocos2dx version 2 code, so I've already worked these out a bit for the gameplay, and get scale factor, like so. Should be a multiplication in here. What that is saying is when we've got a tube, a single tube, we want the largest gap that exists for getting over this tube to the top of the screen, so the top of the tube to the top of the screen, to be the equivalent with our standard ratio of 440 pixels and no bigger. To the bottom of the screen, we want that to be 230, so I'll say single gap bottom. And you'll see in the code how all of these work then. I wouldn't worry too much about them now. I'm going to say single gap max, so the maximum gap that we want with a single tube for the robin to be able to get through, so the maximum number of pixels that the robin can actually get through, we'll say is 280, and the minimum gap against either the top or the bottom of the screen to be 160. So what we're doing basically here is putting a lot of control in as to what the gaps will be to the edge of the screen in the case of a single tube, either one down the bottom or one coming from the top of the screen, so that it's possible for the gap isn't too big, so it's too easy, but it's also not too small, so too difficult. I'm now going to copy these here then, and we're going to, instead of single, just put the word double in, because this will then represent where we have tube pairs, for where we've got both one from the top and one from the bottom, and the robin has to get then between those tubes. And here again we want 480, we want 120 here for the bottom, 220 here as the maximum gap, and 140 as the minimum gap to be able to get through. So again, I've whizzed through that fairly quickly, but just rest assured these are the various controlling parameters that we use to control the gaps and the positions of the tubes. And the main point is that we don't end up with, if you don't do this, you end up with it often spawning tubes which are right at the top or right at the bottom of the screen, so already underneath the floor, or they actually, when they come say from the top down to the bottom, they're actually really low, it's impossible to get under them, and vice versa. It just makes sure that generally they appear more or less in the middle of the screen, and 100 or so pixels either side of the middle, and the same also for the gap here. The reason for the type here is that we make sure that we never spawn the same type one after the other, otherwise you could end up with 10 coming from top to bottom in a row, and the robin simply has to fly along the bottom of the screen, and things are fairly easy. The last thing I need though is I explained that we want to control that when we've gone underneath a tube, either with the top to bottom tube or the tube pair, that we can then guarantee we can get over the next tube. So we'll call this KTube max up pixels, and for now I'm going to set this to 180, and again scaling correctly as well, so that this appears okay. And I've just realized this get scale here should indeed be a get scale Y, otherwise things are going to be dangerously incorrect with the gameplay and not really work at all, because everything has to be scaled against the Y. So that's the now constants now set up. So now we can go into actually programming everything in, and like I said, it's going to be fairly involved, but hopefully all okay. The first thing I want to do actually is go to tube here, C tube, and I forgot to add in the start here that we actually need to set the tube visible back to true, because if the tube has already run and visibility has been set to false inside the stop here, then we need to set it obviously back to true. That was seen in preparation for this video, and now into hello-world-scene.h we can start setting up some of the things that we need. So we'll record a last tube type variable then, just a semicolon, and we'll also then put in here a float and a middle Y. And what we want to do now then is inside the initialization then, inside hello world then, is just to initialize these here before we forget to do it, and I've put a little placeholder in there already to make sure I know where the things are. Game time I've got, good, okay, good. So what I want to set then here is then the game time equal to 0 here, so that the game time obviously is correct then, and then we want then this middle Y then it to be equal to the visible size dot height divided by 2. That's the middle of the screen, you'll see where that comes in relevant. And the last spawn time, so the last time since something was spawned is then set to 0.2, so we spawn the next tube immediately. Again, you'll see how that works. Okay then, so back to hello world scene.h, and the slightly more complicated bit is the various functions that we need to add in then. So I'll put these below the create clouds here, and the first one that we'll call is called set spawn time. And what this function will do is set the time gap between our that we wait till we spawn our next tube or pair of tubes. Then we'll have a function that actually calls the spawning of these tubes, so we'll call it spawn new tubes, and inside this function we'll decide what kind we're going to spawn, and depending on the kind we'll say spawn upper or lower, and then just put a bool in there for is upper. And then we want to, if we're not doing an upper or lower, spawn tube pair. And when we've gone inside these functions and actually decided the coordinates for spawning the tube and everything, what we then want to do is actually get that tube on the screen. So this is called by both of the above functions. So again, we'll call it spawn a tube. Again, bool is upper, because remember we spawn an upper and a lower for a pair, and either or depending on a single. And here then crucially is the Y position for that tube. Remember it's flipped appropriately already. And last but not least, we need a function that will return us a tube. So get next tube from either our array or create us one. So in here we'll either take one that's inactive, already been created inside our tubes vector, sorry, not array vector, and if there isn't one then we create a new one inside here and return the pointer to that. So let's take these functions then and just copy that and add in the brackets. And like you said, it's going to be a little bit of coding in this. I've said already this video is going to go a little bit longer than the previous ones, but it's very difficult to do this bit by bit. It's nice to be able to see the final result. So I'm just going to add in the brackets here, and we'll do all this from easiest first to hardest last. So the first one then is the set spawn time. So we'll say the last spawn time. Oh, I need the ctube prefix, don't I? Hello world prefix. Sorry, I'll just copy that from here. Okay, good. So the first thing we need then here is we need to say that the last spawn time then is equal to 0, and then we'll say the next spawn time is equal to float. And then we want to make a random here, so what we'll say then is rand moduloed by, and this is why I had this k tube spawn time variance, that's why I had that then in a whole number rather than a float, and now we'll divide that by 10, and then we can say plus the k tube spawn minimum time, like so. So that will give us our 2.3 to 3.1 seconds for the next spawn time, and the last spawn time is 0. And in fact that just reminds me of something here. I want to set the next spawn time inside the initialization to 0.2, sorry, and the last spawn time to 0. There's a small error there. So back down to the functions then. So that's the set spawn time now up and working. We'll call that later on. And now let's go down to the get next tube first, because that's one of the easier functions to fill out. So we need our for, and then auto, and it's a tube, and it's inside then, and I don't need the colon here, do I? So it comes after the tube, inside our tubes vector then, so our tube object. And what we want to ask is we want to say if the tube's state is equal to k tube state inactive, so it's an inactive tube, then we can return this tube as the one that we next want to be spawning on the screen. Otherwise we need to actually create the tube, so you should be familiar by now. So we have our car file name, which we'll create with space for 32 cars as is standard, then call get file name then with our file name. Our length is 32, our name is tube, and the extension is a .png. And then I want the visible size here as well, so I'll just go up to the top inside the initialization, take the visible size from the director as well, and now we can create our tube. So we can say ctube pointer to new tube is equal to ctube create with file name and then the file name, which gets us our tube object. And then we scale this tube then in the Y, of course, because everything is scaled against the Y, because that's the important thing. So we scale that against the Y. And now we want to call the initialize. Initialize, and then that's with K, and we'll use the tree speed here, and then the width obviously is the visible size dot width. We can add this now as a child, so add child new tube. My goodness, why is that happening? And with a Z index, with a K, Z index tube, which gets it on the screen. And last but not least, we want to push that back into our vector. So that's our tube then added to our vector, and we can then return the new tube pointed to our object, so we can then use our object. I need a semicolon on the end there. So that then gets our next tube, and the point is here really with this state is that we reuse a tube that we've already created rather than every time we want on creating a brand new one, because if you play then the game for only a few minutes you'll have hundreds inside the array when we don't need them. So the next thing to do is to look at this spawn a tube function. So this is actually the one where we first of all say, okay, we need a tube. So we say tube and is equal to get next tube. So we get a tube. Oops. And now we want to set that the position of that tube and set it moving and everything. So we'll say if it's an upper, so one coming from top down, then what we'll do is we'll say tube set anchor point, as I said, and then we want a vec2, and we want it 0.5, so the middle for the x, but the important thing is we want 0, so the base of it for the y, because it's coming from top to bottom. And then tube and set flipped y, in this case it's false, because it's in exactly the position that the sprite is, and in the opposite case, where it's coming from bottom to top, we do want to flip it in the y. In this case, we want the anchor point at the top of the tube, so we set the y then to a 1. Then we set the y position, so set position y of the tube then to the argument y position, and last but not least, we can start the tube actually moving across the screen. So that then actually spawns our tube. It gets our tube from our array and then starts the tube rolling across the screen. So now things get unfortunately slightly more complicated. We'll go into spawning a tube pair. So the first thing we'll set is our last tube type is obviously equal to a k tube type pair. And now we want to get a gap that we want between them, randomly depending on our constants. So we have k double gap minimum, so the minimum gap, plus, and then we want a rand moduloed by, and we want k double gap max, so the maximum gap minus k double gap min will give us, between our min and max double gaps, a random gap for the tube then. And now we want to position this gap of tubes, or this pair of tubes, somewhere in the y. We'll call that our y range that we have for the positioning then is our k double gap top minus our gap minus our k double gap bottom will give us the range of position of this gap. So we've got our gap fixed by gap, but now we want to know what kind of range of y we've got to be able to do this, and now we can find the top tube y then, so we can say the let's call it top y is equal to then our k double gap top, so the highest up that we want to be able to go with the gap, and then minus rand moduloed by our y range. So that gets us effectively a random position for the tube pair as well on the y. So this is then our random gap, and this is our random position of where the top of that gap is then on the screen. Otherwise the gap is always at the same height. And then last but not least, our bottom y, of course, so the bottom tube's y then is the top y minus the gap. Now the last get under y, so the robin will have to get under the top Y here, so the Y position of the top tube. And now what we can do is spawn two tubes, so we spawn one upper, so it's true with top Y, and then we spawn a tube, and this time it's a lower, so that's false with the bottom Y. And that's a tube pair, then spawned. So now going into the upper or lower, and one thing, this might be quite confusing how all this works. If you really want the detail, then obviously just write it out on paper and have a look, but it's not worth me really going in. All it is controlling the randomness of the gap between the tubes and where it is then in the Y on the screen. Is it higher, is it lower, or whatever. And now we go through the same process now for spawning an upper or a lower. The only complication is we need to know what type we have to decide then what kind of limitations we have on the gap. So the first thing is our last tube type is set to is upper equals true, k tube type upper, otherwise k tube type lower, like so. So we know what kind of last tube type we had. And now we want our Y max, so our highest Y, and I'm just going to take this conditional here like this and copy and paste so I don't have to keep doing that. So our Y max depends on whether it's an upper. If it's an upper type of tube, then we want the highest Y to actually be the middle of the screen. Otherwise, it'll be K single gap top. And then it's the opposite way around then for the Y min. So the minimum Y for our tube, again, is upper. If it's an upper tube coming from the top, then we'll say that K single gap bottom is the highest Y, otherwise, in this case, it's a middle Y. Like so. So we have our Y min and our Y max. And now what we need to do is we need to say, okay, if it's not an upper, so it's equal to false. So if it's a lower type, so coming from the bottom of the screen, then the robin has had to previously get under something, either pair or with an upper. So we need to check that we've got a possible position with our Y max here. So we'll have a look and say that if our Y max minus our last get under Y is greater than K tube up max pixels, wherever that is. So if it's got to get too far up with our current Y max, then we'll set our Y max equal to our last get under Y that it had to get under plus our K tube up max pixels. So that guarantees that the amount the robin has to get up is no bigger than this. And why is this giving me an error? Use of undeclared identifier get scale. No, I haven't put the Y in here. Good. Okay, that would have been very dangerous. Good, so back to where we were. Okay then, so this then guarantees that the amount that we're going up is indeed possible for the robin actually to reach. The next thing then is, now that we've done that, is we can get our Y range. So our range of Y we have available for us of where to position the base or the top of the tube, depending on whether it's upper or lower. So that's equal then to abs of Y max minus Y min. And now we can get the Y position. So we can say the Y position then is equal to Y max minus rand moduloed by our Y range, the same as for the tube pair. And now last but not least, finally, if, and we can say if it's an upper, then we'll say that the last get under Y is equal to our Y position, because it's one coming from the top to the bottom of the screen, so the robin's going to have to get under. However, if it's a lower that we're spawning here, then we'll just set the last get under Y equal to the middle of the screen, like so. And why doesn't it like this? Because I've written Y max with a small m, like so. Okay. And last but not least, then we simply have to call the spawner tube. I'm going to copy that just down from the tube pair below, like so. Except here we send in our argument of is upper, and we send in then our Y position. Okay, so deep breath, that then is done. That's probably the most complicated function of the lot, but basically, again, like the tube pair, all I'm trying to do here is guarantee that it's possible for the robin, if it's gone under a tube previously, to get over this tube, and also made sure that we're controlling again exactly where the tubes can appear on the screen so that we haven't got something right at the top and we haven't got something right at the bottom. And also, if it's an upper type, it's at least below the middle of the screen, and if it's a lower type, then it's at least above the middle of the screen, unless the last upper type was really low. So now a slightly easier function then is to actually spawn the new tubes. So here we'll base this completely on random chance. So we'll say our random chance, or our chance, is equal then to rand modulo by 3 plus 1. And all we're going to say now is if it's a 1, then we'll spawn an upper, a 2, a lower, a 3, a pair. The only thing is if we previously spawned that type, then we'll actually generate another random number until we get something that's different. So here we're going to do something very naughty and make an infinite loop. I'm just going to say while 1, and now what I'm going to do then is say that if our last tube type is equal to k tube type upper, and our chance is equal to 1, so if we got a 1 which says we want to spawn an upper, but we already spawned an upper last time, then let's regenerate our random number. Else, and I'll just copy this if here to be a little bit lazy, if the last tube type was lower and our chance is a 2, so again we want a lower because it's 2, but we've already spawned a lower previously, then we'll regenerate our random number. And exactly the same again, if it was a type pair last time and our chance was 3, regenerate. Otherwise, we're free to generate our tube, which means we can now break with our chance. And then we can say if our chance is equal to 1, then we'll call spawn upper or lower with true, because it's the upper we want to spawn. Else, if our chance is equal to 2, I could also have used a switch, but in this case it's not really too much hassle. Spawn upper or lower, and this time it's false, we're spawning a lower, and I can already here guarantee that must be a 3, so we just say else and spawn a tube pair. And that is that for all of the spawning tubes code. So now the only thing we need to do then is actually go elsewhere into the Hello World scene to get these tubes on screen. The first thing we need to do is inside start and stop clouds. I've already added some code in, which to be honest in preparation for the video I forgot to remove. But inside start clouds, when the clouds first start moving when we start the game, we need to get all of our tubes off the screen. So we need to call on our tubes stop, which you'll see I've done here inside this loop. And then when we call the stop clouds, so when the robin has crashed off the bottom of the screen, we simply want our tubes to stop still, so we call stop all actions. So I'm sorry about that, I forgot to remove those in my preparation for the video. It's hard always to remember where the code is in that you've typed in previously. So last but not least, we can finally go into the game update here, and we can now, if the game over is false, then we can update our game time. So that's plus equals delta time. And now what we can also do is say that our last spawn time plus equals delta time, so the time since we last spawned a tube. And now what we can say is that if our last spawn time is greater than our next spawn time, then it's time to spawn something. So first of all we'll set the spawn time, so we get the next time for the following tube, and then we just simply call spawn new tubes, and that will spawn us a new set of tubes. So I'm going to hold my breath now and compile this, hit build, and hopefully, fingers crossed, this will run and we'll see some tubes on the screen. So starting the application, and some tubes are now appearing on the screen, as you can see. So we have a pair, then we have a lower, then we have an upper. And the important thing, and all these constants that we're looking at the gaps and things, we're basically control that the tubes more or less are in the middle of the screen. And you can see that there's no repeated tube type coming here, so we have a pair there, a lower, then an upper, followed by a pair, then a lower, then an upper, and then another pair, and then a lower, and then another pair. So things are random, but they're not actually following each other, and the gaps are actually looking fairly sensible as well. The one thing that I am noticing here, obviously there's no collision, so we're not dying hitting the tubes, but I am noticing that maybe things are scrolling across the screen a little bit quickly, but that we can easily change. And if I just let the robin die, then everything stops still, and when I start, the tubes disappear, and the game carries on as normal. Okay then. So that's it then for this video. That's the tubes working and scrolling across the screen. Obviously it's not very good the way it's working at the moment. When the robin dies, it resets immediately to the screen. If I just show you the robin dying when tubes are on the screen, then immediately carry on clicking, then the game restarts straight away. So if the robin now dies and I just carry on clicking the mouse, then the tubes disappear. It's not very fine. We need some kind of delay in there, and we need some labels, obviously the score and stuff like that, and we also need obviously the robin to collide with the tubes, which we'll do in the next video. But for now, the most complicated part of the whole application is actually done, and it's this mess of functions here which really is controlling the generation of the tubes and also making sure that the gaps between them are sensible. And hopefully you appreciate also now that the way we've done this with the constants in this file like this is to actually change the gameplay is not very difficult. If we want to change the way the robin responds to jumps or something, we can change the speeds and the gravity. If we want to change the speed of things scrolling across the screen, we can already reduce things by reducing this tree speed here if we want or something. Also the gaps and all between the tubes here, and with the spawn variances and everything here. So we're in quite a good state really to very easily change the gameplay just by editing the numbers in this file rather than having to find things inside the code. So hopefully that made some sense. Sorry it was a little bit long-winded, and comments, questions, criticisms welcome as always on YouTube.